and I was on mute. So how do I get it onto the right camera? Just a moment. Is it plugged in? It is, I think. Let me see here. I think we should be using this camera. Okay. So, welcome back everyone. It's been a while. Hope everyone's doing well and that, you're enjoying your weekend. So, what am I working on at the moment? So, today, as usual, I'll be working on this Seedlang programming language so this is going to be a prototype language used for playing around with different language implementation ideas and features, which I'll be using for a base to develop an alternative to Bash, which I'm provisionally calling Ash. I'm writing it in Rust, and my tooling setup is I use Mosh to connect to a development server. I use Tmux to split up my environment. I use Vim to write my code, and I use ENTR along with Docker to run the project whenever I make code changes. So today I'm going to be focusing on, before I dive into the code, to be a little different from usual, I might just look up. So a friend shared a link regarding another programming language, fairly recent one it looks like, in the same space as what I'm looking to do with Ash. And so I'm going to take a look at that today, just look a little bit at the example code, things like that, and maybe look at a few others of the alternatives that are out there as well, because there are other languages that try to achieve the same thing. Oh, I lost a nib for my pen there. just from messing around. Yeah, there it is. So I'm going to be taking a look at that kind of prior art, see some of the alternatives that are out there. I think Elvish is also one, and the oil language, can't remember what the language part of it is. I know there's the oil shell, I think, and then there's a shell language to go with that. And then there's also, I might take a look at Fish again. Fish has its own, again, is in a similar space, but with its own more C-like syntax. So I'm going to take a quick look at some of those things just to catch up, see what some of the other ideas they're playing around with are, because as I've been working more on my own, my thoughts have changed with regards to what makes sense and what doesn't make sense. So it's useful to revisit those alternatives in a new light to see what I can pick up from them from this new perspective. And so once I've done that, I also I've left a to-do item here for myself to handle out of bounds assignments when doing indexing assignments. And then I'll try and continue on with range indexing and maybe destructuring if I get to it today. Range indexing should hopefully be straightforward enough, but as always, we'll see when we get to it. So the first language I'm going to be taking a look at is it Next Generation Shell, I think. And that's the one that a friend of mine shared with me, and I think there's a tutorial in the user manual potentially. I was looking this up earlier. And so we also have Elvish shell language, and we'll go oil shell, and although as soon as I hit enter I was like, that's going to give me the wrong result. Oilshell.org. Okay. And so OSH. So there's a language and runtime. I remember, yes, they split the language into two parts as somewhat legacy support OSH and then YSH is the modern piece built on top of it. So I think, is the OSH part something you can opt into using, say, a shell opt command or something like that? I can't quite remember. And was there another language? Yeah, the fish programming language. Yeah, so just take a look at what's already out there in this space and what can I take and learn from these ideas. So examples and sample features. So you have standard library instead of repetitive re-implementation in each script. So logging functions and the like. Yeah, that's interesting. And I guess they will potentially have color coding in the shell, potentially, depending on how it's implemented. Running external programs ergonomically. So this one has support for backticks, which is an interesting one because, again, one of the main limitations of this is it doesn't allow nesting, which is potentially a good thing in a way because it, shall we say, nesting can make things more complicated anyway, though it's still kind of nice to have the flexibility. And one thing I do prefer about this syntax as well is I think it's more gives you a bit more flexibility with, or makes the syntax a little nicer if you want to split onto multiple lines, but that's a very subjective thing. So we've got $* values, and so that's potentially interesting as well. So within the context of this, running a program in this way, the use of variables, you can add the $ prefix here, but then when you're, so I think we have the tutorial here. So when you're, and this is something, I didn't quite get when, so this is some example code using curl to access GitHub, I guess, and OpenSSL. So one thing I like about this language is it's very targeted. So it's a modern language for DevOps. So already it's fairly, and same here, focuses on very specific use cases. And I think that's where a lot of language development is possibly going to have to go in the next while. We have so many general purpose programming languages, and that's great, but we've so many general purpose ones now that to actually distinguish languages from each other, we might need to look more at kind of DSLs and languages that are targeting very specific problems. So, and use a subset of bash syntax, which is something that I was playing around with myself as well. I've kind of gone away from it, although I think this language as well uses the not standard, but C style syntax as well. So we can see there's a for loop with your standard looking initialization, condition, and increment. Let's see. What else do we have? So another thing to note here is that variables in, I guess you could call it the default part of the language, don't need a $ prefix. And so when you're running an external command, it looks like in the context of that section of code, so in that scope maybe, you can use dollars, or you use dollars to distinguish variables from, for example, the program name and things like that. Maybe this star does a range operation, kind of like value. So if values is a list, this star will then decompose that into it puts the values one after the other. I'm not sure how they'll be joined. Will they be separated by commas, or will they be separated by spaces? I'm not quite sure. It would make sense to me, at least, that this is generating first the program name and then a list of strings as the arguments, and this then is unrolled into multiple string items in that overall argument list. This is an interesting syntax. So if you run a sub-program with an ampersand at the end, then that will put it into the background, I guess, or run it as a sub-process. So a nice nod to Bash, so that it's maybe a little intuitive and familiar. And so then you can control it in the background. That was something that I was trying to figure out myself, what would be a nice syntax for that. And using dollar with the parentheses makes a lot of sense as well. As I've been playing around with different ideas, I was kind of thinking in the last while of using kind of a dollar approach, and then it would say whatever happens until the next semicolon is part of the command. But having the delimiters using parentheses like this could be useful for formatting reasons, and again the ampersand at the end is kind of nice. Now I would nearly put that towards the start if I were to play around with language ideas here, just to make it obvious at a glance that this program is going to be put into the background. I think that sometimes when you put things at the end, especially if you're going to have a program with a lot of arguments, then this kind of thing can get ignored. So I think the earlier you put those kind of symbols, the more useful or obvious it can be. But again, that's a subjective thing for me. So structured data, that's interesting. So so this isn't related, but if we do 2 backticks and we have JSON, then I guess it will automatically turn that into a JSON object in our local, or a map in our local variable. Now, why you need a specific language construct for that, I'm not quite sure. I guess as a shortcut, to me, I would nearly think that, well, maybe there's a bit of processing that goes on behind the scenes with that. So maybe it will handle different exit codes and only process the JSON if there's a success message. But even still, that's something that I often think about with regards to language features, is when is something better as a language feature versus, and this can be similar in Python or things like that, where you allow operator overloading as well. When is something better to be a dedicated operator or language feature versus just a standard library function call? And that's something that at a glance looks like it could be a standard library item, But what I guess we can do, and is one of the beauties of open source, is that we can just jump into the code base, presumably. And so now the only, what's this, custom properties, allows you to decorate your repo with compliance frameworks. Okay. Now the only issue here, which isn't an issue as such, is the use of the GPL license. So technically any implementation details that I dive into that influence what I'm doing could be considered a use of GPL, which, I mean, I'm planning to make my language open source as well anyway, but it could be something that, I want to make mine kind of BSD or something like that. GPL could kind of complicate things if I dive into the source code, so maybe I'll leave that for the moment. Smart and customizable handling of processes, exit codes, including throwing exception. Yeah, that's something that will be a big part of the language I'm hoping to do. Manipulate structured data, so you kind of have the functional primitives. Groups value into a hash. Counts occurrences, so kind of helper standard library stuff. Let's take a look at the Rosetta code stuff. Plan list, multiple distinct objects. So those are kind of primitive operations, so to speak. Documentation. So instead of looking at the implementation of the double backticks, maybe we can take a look at these. And this also provides maybe a good reference in terms of the documentation that I can provide as well for my language. Wow, this is a fairly nice and comprehensive looking standard library. So that's the global namespace. So I wonder, is that imported automatically? And you've a lot of low level stuff here as well, so you can work directly with ports and things and threads. Whether those are exposed to the user, I'm not sure. It seems kind of a bit low level to be working directly with, but then again, this language is targeting DevOps operations, so maybe that's useful for gluing different programs together. I'm not sure, but let's keep going. So we've types. There's a diff type there, I think, represents a difference. That's cool. Represents a difference of elements between two arrays. And this language is taking an interesting, well, it depends on what level these types are implemented. If they're implemented in the standard library but in the language itself, then that's a bit simpler. But if these are all implemented in the language at a lower level, then I know it's, for the languages I'm doing anyway, I'm not saying that this is better, but one thing I am hoping to do is have very few, shall we say, built-in types, and then have most of the other types be composites of those built on top. So let's see, temporary FS object. So lots of very interesting and specific types there. So string expansion handler, yeah, so that will, so every double quoted string that has $* components, so that will essentially spread the item, if I can simplify, or if I can describe it in that way. Multi-method, set the normal type. Okay, so you set, so when you do dot lookup, and you can overload that. Oh, I see. So this is defining how it gets implemented for each of these different types. Okay, and so it's making, so what's multi-method again? So it's essentially allowing an operator on different types, or method rather, on different types, and then I guess it's similar to a vtable lookup. Yeah, and this is the one that I want to, so it gets the standard output and decodes it. So maybe it's just such a common or such common sequence of operations to do that it makes sense to add it to the language itself. Does not strip trailing new line characters. Nice. But you can provide additional operators to do that. Lots of assert calls, which can be useful in a bash alternative or DevOps dedicated language. Because with a lot of, I guess with general purpose languages, you want to be able to, well, it depends what you're targeting really, but especially with something like, I guess, when it's a tool that non-programmers are going to be using, such as a web app or something like that, then you generally want to be able to handle different exceptions as well as you can, and give, especially if it's the input to an operation is something that was provided by the user, it's useful to be able to deduce where an error came from based on the user's input, so that you can give that feedback back to the user in case of an error and say, hey, you did this thing, that's not allowed, so try again, but do better. Whereas for things like scripts, especially when they're going to be hopefully a bit shorter and used by developers, then having asserts throughout can be kind of useful, so that you don't have to handle all the cases. You basically just handle the happy path for the most part, and if any of the constraints are violated, then you throw an exception, but hopefully a readable one. So let's see, find in path, interesting. So lots of just niceties that aren't present by default in bash, but you'd have to write another program to implement it in bash, or to have that functionality in bash, but it would still be kind of clunky to work with, because if you pass arguments to them, to programs in bash, you have to deal with the automatic handling around strings, the way that bash can handle double quotes and apostrophes differently, the way bash can expand white space, things like that. So having it as a built-in function gives you a lot of benefit just by the fact that it's a built-in function rather than calling an external program. Executes given body times. Okay, so is that a function callback kind of function? Okay, yeah, so you could possibly do a similar thing with a loop, but it's just a wrapper around a common case, I would imagine. get command output and decode it. Initially I read that as structured data when the output can be arsed. Like sometimes your output just couldn't be bothered. So let's see, that comes back. So describe instances comes back as an array, and so you can operate on it directly. And yeah, so that's a commands pipeline. And that's an interesting way of abstracting the pipeline as well. That's something that we've got, standard library.ngs. Okay, and so the standard library looks pretty big, 6,500 lines, but it does look like it's implemented in the language itself. So that's really nice. And so, yeah, whether that's something that makes sense to have as a dedicated operation versus just calling decode. Looking at the implementation might give some more information as well on that, but yeah, it's an interesting approach anyway, just to know that that's the approach that got taken. So here we have the manual, terminology, meta, slot for auxiliary type data. So that could be things like, so meta information is not fields and is accessed differently using the meta method. Okay, so that could be similar to what I'm doing with type methods. So different types. So I guess the probably typical alternative is the way JavaScript operates. And so if you create an object, or most types have an object kind of typing in a way, and so they have, for example, if you create a string, I think it'll all automatically have, I guess in the background it's something like value, I can't remember the exact name, but you'll have this kind of metadata around it as well. So you'll have length, and with maybe an object you might have keys or something like that. And so, but because some of those are living in the same namespace as, for example, if I added my own values to the object, such as x, and I said that was 3, then I need a way of distinguishing between those kind of meta fields and these extra ones. I mean the user defined ones. And in JavaScript, I guess you use the likes of has own property to distinguish that. And I think in recent times you have different alternatives to that, because it's such a common thing to not want to access the metadata. You just want to define fields on your object and access only those, and not worry about the language level fields of the object. And here it looks like it's using kind of name spacing it in a slightly different way. Method, built-in or user-defined functions can be closures. Methods are also called functions in several places in the documentation. A multi-method containing an ordered list of methods. When called, the appropriate method is selected from the list to perform the computation, and I guess that's based on the type of presumably the first parameter. And that's an important thing to note as well, is that it looks like the types are at the user level, so they could be dynamic but strongly typed. So you can provide, for example, a type for parameters to be passed to a function. Maybe, I think I saw that a while ago, but let's see. So fetch that will decode the JSON returned and return the data structure. Use read to get raw contents. Cool. And that will decode the command output and return the data structure. So similar to that, but will also run the command. And ... will be parsed even further. Okay. I mean, that's interesting and useful. It seems a bit kind of specific, if that makes sense. So these seem to be kind of narrower use cases, but then this is likely a person who's using DevOps or writing DevOps scripts every day. So compared to someone like myself, I do a fair bit of DevOps operations as well, but I wouldn't be doing, as far as I read from the developer's own website, I think they've done a lot in things like Terraform, CloudFormation, all these kind of things, whereas those would be things that I'd have used more. I wouldn't have had as much direct experience with those. My own experience with DevOps will be more writing lots of dedicated scripts for gluing different parts of the build pipeline together and things like that, and setting up build processes for projects and things. So slightly different use cases there, I guess. So this is likely very useful, but wouldn't be something that I'd be as familiar with. Or maybe ... isn't a specific operator, but is actually the idea of, if you pass commands to the AWS command, AWS itself will be handled specifically, I guess. So I'm just going to grab a quick drink. I'll be back in 1 minute. Okay, so uniformity, that's really nice. I like that as an idea. Trade-offs between power and not allowing to shoot yourself in the foot are resolved in favor of the power solution. Interesting. Languages aimed at experienced engineers which use their own judgment should be powerful enough to shoot all feet in the building at once. Yeah, that's an interesting one. I wonder which I would be in favor of. It depends what kind of shooting yourself in the foot you're doing. I mean, in terms of the language itself, the worst thing that I imagine you could do is run an infinite loop or leak memory or something like that, all of which are basically resolved once the program itself finishes. I mean, if you want to limit the damage done by, for example, running a bad AWS command or something that would actually cause potentially bad ramifications, then I feel like there's a limit to what the language can do to protect you from that. I wouldn't see that as the scope of the language in general anyway. So I'm curious to know what the intention behind this paragraph is. Simple methods naming for less guesswork. So that's basically saying, okay, they're overloading the plus operator. I wouldn't like this so much. I nearly prefer the JavaScript approach, which is the one I use for that reason. But this idea of, you know, X's, Y's, and so on, so you can add different properties at different points of this declaration. And I mean, that technically is the same as that, though I think this is a little clearer, a bit more clearly saying that this is producing a new object. But I mean, as long as the language just tells you that this produces a new object, that won't be difficult to remember. I guess it's just what I'm used to as well, so I don't think there's anything inherently wrong with the plus operator there. Just like I say, not what I'm used to. Can be extended to decode your format. So okay, so it'll actually, so the multi-method on the same link twice, but it'll actually change the decoding based on the extension, which is interesting. I wonder how it handles that. So whether multi-methods, yeah, I guess that's something that I just have to read the documentation for. And actually, now that I see the cursor on the site here, there's a lot of documentation here. That's very impressive, though I think it would be a bit useful to have a sidebar here that had links to the different sections. Yeah, that makes sense. Having two syntaxes, command syntax and code syntax, and that's kind of a similar idea that I came to the conclusion of as well, that when I was doing the initial playing around with ideas for Ash, then I was thinking just have one unified syntax, but with the unified syntax, it basically means that if you want to run commands simply in the bash style, then you need dollars before all variables. But the fact is, you access variables in general a lot more often than you run commands, especially the more of the in a standard bash program. You tend to use commands a lot because you're running programs to perform operations that a lot of other languages would just have operators for. So as you move more of those operations into the language, there becomes less and less necessity to actually run dedicated commands anymore. So you end up having a lot of your script just be regular programming with a sprinkling of commands, is what I've found a bit from some of the examples I've done anyway. So let's see, motivation: can I imagine any syntax for a real language that I would like, which is built on top of the command syntax, which is similar to bash? Yeah. That's why it is 2 for running external programs and IO redirection, where this syntax is very convenient. Yeah, that makes sense to me. Simplicity: types with a simple type system geared towards multiple dispatch, no classes. Okay, so when it says no classes, it's using multiple dispatch in place of that. Okay. Multi-method, so you're allowing overloading, closures, and exceptions. Yeah, I think exceptions make a lot of sense for a language like this. So let's see, read, which reads from a file, can be extended to support HTTP or S3. Again, a lot of So extensibility, I mean, I would nearly be saying this is in contrast to composability in this case, because you're kind of saying, okay, well, this one thing can do these multiple different things based on stuff that you bake into it behind the scenes. Whereas I would nearly be in favor of saying this thing does one thing, but it can be composed with these other ways of providing in different inputs to this same thing. So you can see what I mean. Instead of having a read operation that can easily do read from github.com, which does a HTTP request, and one that does, my file.json, I would nearly have that be explicit, either namespaced, and then have some kind of operation afterwards that, if, again, it depends, it's kind of tricky to, what am I doing here? HTTP read, fs read, and then pipes into, well, I'm not even sure what can be extended to support HTTP or S3. I mean, yeah, instead of doing dedicated files, I would nearly, or dedicated implementations that go under the same method or function, I would nearly just do different implementations. I'm not quite sure what I feel like this, having it be able to do different things. Now I'm not sure that that's how it's actually called, but in general it kind of comes back to overloading, in my opinion, and I think often just giving them different names to distinguish the different things that they're doing kind of makes sense. I mean, this can be kind of useful as well if you are just passing through a variable that has a location, and that location could be a HTTP address or a bucket or something like that, and so you don't then at the end have to do a match on the type or something to figure out whether you should do read fs or read HTTP. But even so, I would still prefer the latter, just to be a bit more explicit about it, because I feel like it makes it, this kind of overloading to me can kind of harm readability. But again, that's a subjective thing. Most of the syntax is just sugar for calling methods. This behavior lets you define any operator for your existing or your custom types. And that's an interesting point as well, actually. And that, so, I mean, any of those kind of operations as well are, for example, the dot operator is a method that you can define on the different types as well. Now, it's I wouldn't expose that to the user. Like I say, I wouldn't be a big fan of overloading operators and things like that, but in terms of language implementation, would that simplify it? I'm not sure, at least for my language, the way I'm implementing it now anyway. I'm just thinking, if you have this dot operator work the same way, whether you're doing an assignment or a retrieval, and have that just be a function regardless. I'm just kind of thinking, is there any way I could use that idea to make my language simpler in terms of implementation? And I don't think so off the top of my head anyway. But that might be something that just bounces around in the back of my cranium and might help me come up with some simplification later. So I spent a good deal of time working through the ideas behind this language as well. So I'm going to want to actually just breeze through the others and get started with my own coding soon enough. Command syntax. So very similar to Bash. So again, we've got redirects, which is similarly something that I would actually do without. I'd nearly work with pipelines and do something like curl github.com and whatever I have there, and then pipe it to a write operation. And one benefit of piping to a dedicated either external or built-in function is this can allow you to provide basically different parameters to your write program or function. So a very common one I would say would be if I want to redirect output and I don't want to overwrite the file, I actually in Bash have to do something like a set opt no clobber or something, and then that will modify the redirect operator so it doesn't overwrite that file if it already exists. Whereas if we pass it to a program, we can just do something like that, no clobber, or depending on what you decide your defaults are. But I think that now it does suffer from the fact that, and again, I guess this is what more purists would argue, is that you're calling an external function to do that. But as I mentioned before, I feel like, but again, I haven't tested this either, but just intuitively, if you're streaming a lot of data, then that call for an external function probably isn't going to be your bottleneck. It's just going to be the amount of data that you're consuming is going to drive how long your program is running for. But then that's something I have to research a bit more as well. So I would, be more in favor of not having dedicated operators for reading in and writing out data, which potentially simplifies the language as well. Code syntax resembles other languages. In the code syntax is the syntax of those switches to the interpreter. So if I pass P, yeah. So in command syntax, it's possible to switch to code syntax in the following ways. Okay, so that's cool. So you can create a block. So, or does this create a block? So what's happening here? So we've got ls. I'm not quite sure what ls is doing here, but we also have, let's see. So this isn't running a command, this is running code. Code that computes the file name and returns a string. Spaces don't matter, expanded. Okay, and so this will do a different amount of, I guess, post-processing depending on the symbols that come before it. And so in code syntax, it's possible to switch to command syntax in one of the following ways. So we've got command syntax here, and we've got it with appending there. capture output and decode it. So straight away we can access it like this. Yeah. And then get a reference to a process using that. Yeah. So we have comments, variables, scoping rules, that's all good. Local to a method, local to the enclosing method. Interesting. I wonder what the use case for that is. And we have global variables. Now with the syntax that I have, because you've a somewhat unified declaration syntax and separate assignment syntax, the declaration syntax basically automatically defines the scope of a variable. So if you don't know the value of the variable when you're initializing it, you just use null or something, but it means that you specify the scope of the variable, I guess, very explicitly without the need for any of these other declaration primitives. Modifying a variable scoping. Okay, so it used to be one scope and then you changed the scope. So yeah, that's something that I don't have, and it's something that wouldn't really make a lot of sense to me. But again, there might be use cases that the language has in mind that I'm not thinking about destructuring assignments. So that's, I think, is that what Python uses for gathering the rest? Whereas I use ... That's the only difference there, I think. Methods and multi-methods. So methods names have those. Okay, so lots of symbols are allowed in method names. Okay, and multi-dispatch. So I think it's methods in general are defined with a capital F, which is an interesting syntax. I mean, I just use FN, which isn't, I mean, it's kind of much of a muchness, which one, I mean, like FN is so short as well that it's not like it's clearer than capital F. Capital F is just such a new way of doing it. I mean, you never see a function definition keyword starting with a capital letter in general. So, but that seems pretty tidy. I mean, it doesn't look like there's anything wrong with it. And so let's see. Yeah, so you can provide types, and I guess it will decide I wonder, will the other parameters also determine what method gets dispatched? Based on all of the arguments types. Okay, it scans the method list, or the methods list backwards, so it goes from the bottom to the top to decide which one gets run. So the methods list from last element to first. Okay, so it's the first one to dispatch. So if you could actually shadow an earlier one with this method, whereas rather than the most specific method being called. And it just checks, do the types match up? Okay. Okay, and so there are type definitions. Not really sure what those do, but anyway, there's a lot of content here, obviously a lot of functionality. Down here we have flow control finally, and language gotchas should not be your first language. Watch the version, namespaces, mutable parameter gotchas, that's like in Python. Type system is only used for multi-dispatch. Okay, so I wonder, does that mean that? Yeah, it does. So it doesn't mean that I guess you couldn't do a thing like declaring a variable of a certain type and then raising a panic or something if you tried to do an assignment with the wrong type and things like that. But that's interesting. I mean, it does mean that if you, I guess if you had a function and you passed certain parameters to it and you just didn't have, so if I defined ff and I had a string, oops, and I called f1, it wouldn't panic saying that, I'm guessing it wouldn't fail saying that, oh, this is the wrong type. It would say no function found with this type, I'm guessing. Which, to me, again, that would be one of those things where one of the reasons why I prefer not overloading, because when you do a lookup, especially when things get a little more complicated, being told that yes, this function exists but not for that type, well, if the error was described in that way, that yes, there is a function but no, it's not for that type, versus this function wasn't found, which can sometimes, depending on the language or how the errors are described, that can sometimes be the case as well. I mean, that kind of an error I would find difficult to debug, because I'd be like, the function is right there, just call it. So yeah, that kind of stuff is frustrating when a thing says, oh, this thing couldn't be found, and you're pointing at the screen and you're saying, just look there, it's right there on the screen, I can see it, how can you not see it? So, but again, it depends on how the errors are handled and described. A hook is a hook object called by, so is this kind of like a utility for debugging potentially? So we create a hook, and then when we call hook, all the blocks inside it are called. Very interesting. Actually, that's something that I'm looking forward to hopefully implementing, maybe in this language as well as the language that I develop on top of it. But the thing I'm interested in developing in is a debugger, and I have a few ideas for how that will be implemented, so I'm looking forward to playing around with those. Exit hook, very useful. Yeah, actually, that's a nice idea, and that's very useful for bash scripts. Now, one of the reasons it's I kind of use them a bit, like, I think they're very useful in bash scripts, but that's also because bash doesn't really have good error handling in general. And so having exit hooks that allow you to do a bit of cleanup is very useful. Now, the language I'm thinking of is hoping to have good error handling, but at the same time, I have good enough handling for when an error gets returned or an exception gets raised from a specific point. Yeah, so let me describe what I'm talking about here. So if I run a command and I say, I don't know, ls abc, and that file doesn't exist, then, and if this panics, the language I'm playing around with, so I can't remember where I put the question marks. I think I was putting them at the end, but it might have to change for for commands, we'll see. But the idea of the question mark is that will catch the error and you'll be able to do some error handling maybe. So if not okay, then do ABC. But then that's nice that there's an exit hook that you can do it regardless of where the program exits. But I guess a way you could still get the same functionality in my language is by making sure that your whole program runs in a main function, which will be a good practice that I'd be suggesting anyway, because sometimes when you put everything inline in a script, as the script develops and it's like 100 lines, then it becomes kind of a 100-line main method. So I think it's good practice to put the majority of your program in the main function from the get-go, and then that will allow you to, when you do call main, you can have a catch-all, shall we say, this is essentially a try-catch, and you can have a catch-all thing here, and you would say, if not okay, then do your cleanup. But then the only thing is you don't have access to all the values that would be in scope. So that's something else that can be useful from the exit hook. But then if you're talking about values that have been initialized and created and are in scope, you also have to deal with the fact that they might not have been created at the time that your exit hook gets called. So there has to be a bit of playing around with that, but that's a nice idea that I might play around with, or at least, shall we say, think about a bit more. And I really want to start coding soon, but whoops. Let's see, so swap back here. Patterns, yeah, so that's kind of JavaScript style. Iterators, executing external programs. So we've a % operator as well for running the process. Okay, so yeah, create the pipeline but do not run it. That's something that I was playing around with, or it was something that made itself apparent to me as well, the need for it. So you're kind of, it would be similar to what you might say in the likes of functional languages, currying. So you can essentially initially populate a command and maybe give more parameters, build up the parameters as you're going, and then execute it at the end. And so adding each parameter kind of gives you back a new instance of that pipeline with those parameters added, so that when you run it at the end, you're building it up piece by piece. Yeah, useful for passing ready to run commands around. So very simple. Now, I was also thinking that as I was playing around with that idea, that it's similar to currying, but in a similar way, currying is a neat idea and it's fun to play around with. But at the end of the day, I feel like you get the same functionality just with anonymous functions. So you could also kind of just have an anonymous function here that runs ls / and returns the result. So whether that needs its own thing, I'm not sure. So for example, this could potentially be done in a similar way to, let's see, again, I'm using my own syntax here. Now mine is a bit longer, and I'll fully concede that, but you then run it using that, and you kind of get the same result. it's much of a muchness. I don't think one approach is necessarily better than the other, but the at least when I was thinking about it, I was like, is this something that's actually needed? Is this a language feature that would provide enough value, and also is the cognitive overhead of learning a new language feature, does it provide enough return on investment? I mean, it's a simple thing to remember in its own right, but still, the more features you add to a language, they do build up over time. And it gets to the point as well, like in Bash, where there's just so much syntax that, I mean, if the language is small, that's fine because you've a limited amount of syntax to remember. But then you look at something like Bash and the comparison operators and how you have to use double parentheses if you want to simplify your arithmetic expressions and things like that, and then you've different string manipulation shortcuts as well, that each bit of syntax takes a little bit more space to the point where you've just so much syntax, it's difficult to keep track of it all. Now, I'm not saying that this language is suffering from that. It seems to be relatively lean and nice from that regard, but it's worth considering when you're adding more language features, just to make sure that each one is actually contributing something valuable. So, syntax substitution of command line arguments, syntax for options. Yes, and this is an interesting one. Alter the behavior of execution of an external program. And the way it does that is by providing key value pairs. So altering the behavior and also altering things like the directory that it's running from. So CD is a bit of a kludge, I feel, for bash scripts and things, because you're altering the syntax of, or you're altering the running directory for the whole program, whereas I think that could nearly be a thing that's nicer to parameterize, is the working directory of a, and it makes it more explicit in that way as well. But that's, oh yeah, and so internally the ampersand sets the ampersand option to true, and it looks like you can, oh no, that's just the output, and it outputs the type of the command pipeline that gets generated there as well. So we've input output redirection, and yeah, those are kind of the places where I'm like, it gets a bit unwieldy. So you can overwrite that file from standard error, and then that's append, and that's capturing standard error so you can send it to another program, I guess. And all those kind of things just get a little bit fiddly. And there's, I mean, at least with these, it composes nicely enough, but then you also have, in the likes of Bash, you have support for ampersand, but then I've found in some environments it doesn't work the exact way you would expect. So those are kind of some of the reasons as well why I'd be more in favor of having a simpler, piping to a simpler write function or program that takes parameters to say, you know, instead of having all of those guys, I would say something like, yeah, what would be my alternative for those? Let's see. So for the first one, I would go my program, my arg123, and we would pipe that to write my file, and then instead of read from, I'd probably do something like just cat my file, and so here we would do write, maybe append, and this would be overwrite. So overwrite would be the default. Oh, but that one's doing standard error. And so and that's something that I still need to figure out is the syntax for redirecting, for defining pipes, essentially, because again, that's a thing where there's so much. I mean, the simple stuff is straightforward enough, like piping standard out to standard in of the next program, and maybe adjusting. Well, to be honest, as soon as you get into redirecting different numbered pipes, anything besides the very simple stuff, because even behind the scenes it's doing things like dupe, file descriptor, and redirecting file descriptors and all these kind of things. I was thinking it would be nice if you could have some kind of a simpler mechanism in between there to just define how you want what direction you're wanting your pipes to go in. Now, it's a bit of a heavy duty solution, I think, to something that doesn't really crop up too often, but when it does crop up, the bash solutions can be so tricky to work with. I find that it would be worth having a more robust, well-rounded solution for that. And so append would have been the same thing. So you do whatever here to get your standard error redirect to this pipeline. So that's one of the things as well. So maybe in my language you would define a different post process for the different pipelines like this. So append my file, so you have, or .error, something like that. But even that can be a bit tricky because you're kind of splitting up the processing, and maybe you want to, I know it's a can of worms in a way. I've a lot of thoughts about it, but nothing concrete, so it's kind of difficult to talk about in that way. But okay, I'm going to try and finish off. Just scroll to the end of this document and see if anything else catches my eye. Yeah, I saw the discussion about declarative primitives earlier as well. Anchors debugging. Okay, that is fine, and that started in 2015, so this has been going on a while, so it's fairly, the feature set seems fairly comprehensive at this point. So let's see, when did this get started actually? At least this is a bit more forgiving, BSD2. So how many releases do we have? So it was Ilya did NGS Lang. And I can't see anything obvious. So we at least have the Git attributes was from 11 years ago. So again, very well established language here. And yeah, this is what I remember as well. So powerful pipelines, it was doing as, yeah, so it had a lot of standard library stuff from what I remember. Intuitive control structures, directory history. Yeah, so this was an integrated shell and language. And so, no, I probably shouldn't dive too much into the language itself. pipeline definition code chunks. Okay, so that's blocks essentially, I guess. Yeah, and that's kind of nice as well. So you can use that to compose pipelines. Now I wonder, is there the same carryover of standard in and standard out as there is with programs? I would guess so. Fail command and caught with the exception capture. Okay, so they're using a similar idea to what I was hoping to do and what I've tried out in the past as well. So let's take a look at exceptions. Oh, that's where I was. If an external command exits with non-zero, yeah, that was something I was hoping as well. Ordinary built-in commands raise special flow control exceptions. Oh yeah, that makes sense. For while and peach commands. So what's the peach command, I wonder? Capture break continue while function modifies its closure to capture return. Not quite sure what that means. One interesting implication, flow controls are just ordinary commands. You can build functions on top of them. Oh, weird. Yeah, so the break can exit the function. So that gives you somewhat, shall we say, Rust-like functionality. Not quite sure how I feel about that. And the return flow control exception is only captured by functions defined within FN. It falls through ordinary lambdas. Okay. So that's kind of what you'd expect anyway. I'd like to learn more about the exceptions though, and also peach. Let's take a look at that. Oh, and I saw reference to... Oh, that's the only... No, that's the only reference to peach in the document. Is that a typo? Maybe each command? Yeah, I wonder if that's just a typo. So let's see. I mean, a lot of this stuff bodes well as well in terms of the language that I'm hoping to write, in terms of its necessity or lack of necessity, because there is a lot of prior art. I feel like that a lot of the ideas I want to play around with already exist. I mean, I've looked at a lot of these before and decided against using them for various reasons, but again, after doing a certain amount of language implementation and revisiting these, it's interesting to see them in a new light, and so it might actually cause me to reevaluate some of these languages in terms of my own usage. And maybe, I mean, it'll still be fun to write my own language and play around with ideas and things like that, but maybe I won't actually need to use it, if that makes sense, because the existing solutions actually, maybe I just didn't understand the documentation well enough, and if I play around with it in a different way, they can achieve the same goals that I was trying to achieve. So an exception is a pseudo map with a reason field. Yeah, that's similar to what, so I'm guessing that's similar to an object in the language I'm thinking about. There's no literal syntax for exceptions. Yeah, so that makes sense. Oh, and it can be thrown and caught, yeah, with the try special command. Sudo map, if the type is fail, if the type field is flow. Interesting. So you can modify how it gets handled. If the type field is pipeline exception, it was a result of multiple commands in the same pipeline raising exceptions. It then contains the exception if the type starts with external CMD. Okay. So, and I would like to learn more about the question mark. Okay, exception capture. So is formed by putting that around a code chunk. It runs the chunk and evaluates to the exception it throws. If there was no error, it evaluates to the special value $OK. So is dollar maybe an equivalent to Ruby single, or are they called atoms or atomic literals? Can't remember, but I'm guessing that's what that means. Now, one seemingly obvious potential limitation here is that you can't actually get a value back from here. So we've got commands that may fail that can return an error, but what if it returns a value? So exception captures don't affect the output of the chunk code. You can combine output capture and exception capture. I'll be honest, wouldn't be a huge fan of that. I feel like it'd be quite straightforward to simplify that to an expression that looks like that. And I think you lose very little, if any, of the expressiveness. Again, that's just my own opinion, but I would find that quite difficult to, I wouldn't be a big fan of that approach. Braced list, okay. Oh yes, so this would be a similar thing to in Bash as well. So you can get the nearly kind of Cartesian product of all of these. Interesting. I'll close that. I've gone way over with regards to investigating other languages, but since we've come all this way, no, I'm not going to read all of that. Is there any quick tour of YSH? Let's see. Yeah, so it's very Bash looking. 3 kinds of substitution. How are expression. So let's take a look. I think arithmetic is, so that's deprecated. Use YSH expressions. So, and it looks like by default variables don't use dollars. Example of a YSH module. So we go declaration with a guard. I think having guard stuff in, actually that's nice that again it has a main call. I think guards that's the type of thing I feel like it could be nicer to have built in support for. So maybe this is to prevent it being imported multiple times, so it's kind of like PHP include once, except you handle it in the callee. But I think stuff like that, if you just, and again this is without knowing more about the use case, but I feel like that can be handled with a slightly better import system. But what do I know, that's just a guess. Optionally declare binaries used. Okay, interesting. So maybe that's for static analysis. Define a logging helper. So source that. So that's kind of your import. So it's kind of trying to do not backwards compatibility, but again, using that source. And maybe that's the reason for that as well. That source mechanism. So again, trying to be bashy with it, but I'd nearly be more in favor of using a more strict module system or import system. So we've a constant declaration, we define a new process. So I guess process is the same as function. And so this is interesting. So how does it distinguish between regular or standard expressions versus calling a process? Is it going to be bash like where everything is calling a process? And if, sometimes it'll be a built-in process, I'm not sure. And it's doing the if test thing as well. Yeah, I think that's possibly how I'd handle that too. It is with call to test. Could also handle it with the square brackets approach too. Again, that's something I'd probably distinguish using a linter to make sure that you're consistently using one or the other, but that's something to play around with. If is main, and that's kind of a Python ism as well, I think. Is main, I guess, is something that's imported from the global standard library, and it allows hyphens in the names too, which makes sense because programs can be called in that way as well. Yeah, so it's difficult to get a good feel for the language just based on that, but I do want to start my own coding soon enough. And I think Fish is, from what I recall, quite similar to Bash, but you do have some niceties in terms of, I thought there was more of a C-style syntax for loops and control flow and the likes, but it looks like it uses the standard keyword approach. Yeah, there's a lot of documentation for a lot of these, and sometimes it can be difficult to cut through the general details to hone in on the details that actually matter and make an impact. But that's more than I'm going to have time for in a quick stream. That'll be more offline research and background research. But it would actually be interesting. I mean, possibly the best way of comparing these would be to take a certain group of scripts and just write each of them in the different languages. And I could write it in the language that I'm planning as well. And that would actually be a very interesting project in its own right, and a very good way of comparing the different environments. So that might be something to add to the old to-do list. So what are the languages? So we have NGS, we have Fish, we've got YSH from the oil language, and we have What was the other one? NGS and Elvish. Okay, finally I'm back to my own stuff. So let's see, we're wanting to handle an out of bounds assignment with binding. So let's see. So first we want to write a test for that, I guess. And we go standard out, indexing. And let's see. Well, no, it'll actually be in the runtime errors file that we'll want to do this. Do I have an out of bounds? Yeah, so I'll put it close to that, out of list bounds assignment. Test file didn't find the end marker yet. I accidentally left some code there. Forgot how long the compile times were here. It would be nice to be able to somewhat selectively omit certain parts of the code base while you're developing, so that you can iterate quickly. But however, so it panicked, which is kind of good. I mean, we want to, I mean, it means that the test did the right thing, but this is where we want to actually be a bit more practical around how it's handled. So we'll go to eval-mod and we'll go index and we'll return the same, so it'll be out of list bounds. So if n is less than 0 or n is greater than, let's see, RHS, or its items len, and if it's greater than or equal to the length, then we'll return that. And it'll be a new invalid bind error. I think, oh no, that's different, so I'll have to do a new location error. And index will be n, though I'll probably have to clone that. And I'll want to change that to 3 just to confirm that I'm checking the list length correctly. I should recheck the bounds. Is use very nice. Oh. Yeah, so it's a U size, so if it turns out to be negative, then actually evaluating the expression will return the, yeah, so do I have negative string index? Yeah, index can't be negative, so we'll get that by default before we even try to do an assignment. Yeah, so that's cool. Now I should re-add a test for 2 as well to ensure that that works successfully, and actually just by adding it there, it'll confirm that the error is being raised here. And so it'll confirm that it's being raised on the third line and not the second line, so that it's the boundary conditions are being tested properly. Yeah, and so that's that done. Okay, so that looks like I'm forgetting a semicolon somewhere. Oh no, my language doesn't support let. So there we go. I have to remember how to write my own language. Or write in my own language. So the next bit was range assignment, wasn't it? So I think it'll be in the old so I don't actually have support for that in the old version of the language. So I might, oh yeah, so this is actually line 3, character 1. So actually I won't add support for range indexing assignment. It wouldn't be the most difficult, but I can, if I can put it off till later, I will. Just because I have other bits that are a little more relevant. I mean, assigning to a range index in particular, I wouldn't imagine is a very common operation. I mean, if I think about languages that actually have that and you kind of make use of it, I really just think of APL, which isn't a good sign for practicality. So let's take a look at destructuring instead in that case. So destructuring happens when we're doing a bind object and so, or rather, if we have a literal on the left hand side. So we'll start off with, let's see, what's in my list? Object. Yeah, I guess I'll go ahead and do object destructuring first. I wonder will a test fail when I change this? I'd say not, but I'll just add new tests for this functionality, and so it calls bind object. And it looks like bind object also has a helper there. Bind object pair. So let's see, where are we when we compile that? Or I'll do some initial surveying of the landscape. So we've got context scopes, names in binding. I think I renamed that. We have left hand side, which is a vector of props. We don't have a concept of mutability just yet. We have the right hand side, which is the, let me see, have we a simpler type alias that we can use for that? So an object is a B-tree string. Yeah, so I think I can change that to an object. And I wonder, can I is there any list of prop items there as well? No. So that essentially, yeah, that's the AST expression, and this is the evaluated value that will be bound to it. BT, I'll call that bind type for consistency. Okay, and I mean, the parameter signatures aren't very clear in general at the moment, so I think I can remove that comment. Left hand side is an expression, right hand side is, I would say, a reference to an object at this point. The item name. Okay, I see what it means by not being very clear. So bind object. And can I do a match eval expression here? I'd say I can. So VHS props here, and although I'll leave it the way it was to begin with, and then I will simplify it. If I can. Yeah, so I guess I better just make it functional first, as usual. Whew, a lot of errors. So where should I start? BT wasn't found, so that should be bind type 262. So that would be B3. And I wonder, is there a way of me defining that elsewhere? Well, there's a lot going on in bind object. I'll probably have to split that up a little bit just to make the commits a little simpler. Although, no, they're just handling prop items. Let's see. I also had bind underscore, and I think that's called bind next now. What's happening here? Yeah, maybe I'll focus on this first because it's a fairly small function. So when I do eval expression to string, and the description is property, and this should be item name. And yeah, that will be an object index field, or it'll probably just be eval Yeah, I'll leave it as eval object index. Remove that, I think, and I think that can be removed. I think eval expression to string automatically does UTF-8 now. New right hand side, that should probably be evaluated before the name. Or no, we'll do it in reading order, at least Western reading order, left to right. Let's see, so we do, we need to evaluate the name first anyway. So we get the value from the right hand side. Where's raw name used? Oh, it was used to get the UTF-8 and then that got renamed to name. Go to mod and we see what we get when we do a prop lookup that fails. Prop not found. Yeah, it would be nice to do a location error. I guess I'll be able to do that by decomposing the expression. So that'll be more or less good to go like that. And then we'll have bind next as well. And if the bind fails, let's see, I'll be wrapping that error. Something like that. Yeah, I'll probably want to add some context there. And so what am I getting? So when I'm attempting to bind next, when Do I add new names to names in binding? I wonder. Not sure. So at this point, LHS is still an expression, even though I should be passing some kind of a refinement of that, I feel. New RHS, well, it's just passing LHS as is. New RHS is a new any kind of value that gets returned from here. Bind type, yeah, is the same as before, and that defines whether it's an assignment or a declaration. And I think the difference between bind next and bind next name is the type of LHS. So I think with bind name, okay, LHS is an expression. And for bind next name is a string and its location. So here I would say I'm doing bind next, which will probably call bind next name for me. And I think I will, so for the new location error, I'll want to extract that from the left hand side. Again, a bit messy here because there's a good deal of duplicated code, but it gives us the correct error line information. So where are we in terms of the compilation of this so far? Okay, still a fair bit to go. So I'll take a look at the errors in this function primarily. So expected a reference. So I just need to, I'll probably do that. Yeah, I don't think I need to change it throughout. 334 expected a tuple but found a string. Okay, so yeah, I swapped it to the old setup, but I thought I was swapping it to the new ordering, but I got that wrong. Same for that. usize can't be dereferenced. That'll be changed now that that's being borrowed. 307. So yeah, let's take a look at some of the low-hanging fruit here. So Okay, so I might not need to add the name here because I have it at the higher level, although it's only evaluated to a string down here. Where is prop name defined? So am I getting that? Am I evaluating that name twice? So this is going to be the pair on the left hand side, and I've got the prop name there. I'm doing right hand side keys remove prop name. Not sure why that's happening. I'll have to rewatch the stream where I added that previously. But let's see. So we've bind object pair and it's evaluating the property here. So why am I doing it again in this place? I'm doing it so that like I basically I'm doing that, and I'm doing it so that the error, well, first of all, so that I can remove it from the right hand side keys, and also so that I can have the error in the message, but I'm re-evaluating that in bind object pair, so I should repass that instead so that I'm not duplicating the effort. And I guess right hand side keys is created up here. Yeah, so I'm duplicating I'm collecting the keys from the right hand side, and so that's to ensure we don't. Oh yes, so it's for the gather operator, and maybe I'll omit that for the moment. So bind object gather. So RHS keys is just that for handling unspreading or gathering. And I don't think do I have handling for spread operator either on objects at the moment? Let me check. So that is in the AST, I believe. Prop item. Okay, I do have is spread, but I don't have is unspread. So that will be a new location error. I'll add that in a moment. So I'll remove. So I don't need prop name here anymore. I possibly just duplicated the effort here and in this function just to keep things simple when I was implementing it first time around. I can remove right hand side keys here as well. LHS len isn't being used anymore. Prop item, that index isn't being used anymore. Wonder what it was being used for. So I have a copy here. Match. I was it? Enumerate. And that was being used in unspread. Okay, so I don't need that for the moment. So on the left hand side, I don't have expression information anymore. Well, each prop item is an expression actually, isn't it? So let me see that. Yeah, so the name is an expression and the value is an expression. And so when I'm wanting to have a location error, it's going to depend on the prop item. So let's see, prop item again. So if it's a single item, yeah, we'll take the expression there. And this will be return new location error. We want to have, let's see, so there's going to be spread on object destructure. And don't need any parameters to that. The name, we're going to verify that the expression is like that. And yeah, that's going to be a tricky condition to describe, but essentially handles the case where, let's see, so I'll just call the test X for now. And an example would be, let's see, if I had an object on the left hand side and an object on the right hand side, but the expression, so it was a single expression here, but it wasn't a variable. So if, say, it was 1, then it would say can only use variable name for object property shorthand, which isn't a very friendly message, but not really sure what else to call it at the moment. And so that creates an item name expression just so that it can pass it into bind object pair. I think it would make as much sense to pass it as a string. I'll just call that name2 for the moment so that I can keep track of it in my head. Though realistically, should I? Yeah, I'll actually hold off on optimizing it until I have the thing working. So for this fellow, I'm going to say it's the same as I have in mod, I think. And it's accessing single. Oh, maybe not. Oh yeah, object prop shorthand, not var. And this will be bind object pair failed, and this will be bind object single failed. And it carries name. And whether I'll add, yeah, I think I will be adding name to that message, but not right now. So how are we for errors? Doesn't even give me the count of errors anymore. There's probably so many. So 313. That's not there anymore. So let's recompile. And actually, if I do, so I added, I guess, a bug fix in the last commit. So I'll actually stash that, go cargo Tom L, oops, bump that, recompile, amend that, buckets dash pop, restart again, and I'll bump my TOML again and actually start that too. And yeah, it's gonna block, I guess, waiting for some previous instance of the build. So let's see. What else have I got to do at this point? So I've gotten my new location error information. That's taken a while. Is there anything I can be working on in the meantime? So we've bind next name. Yeah, and I'll be replacing that as well. So that'll be a new location error too. So that's a prop access on a non-object, value index not assignable. That is object destructure on non-object. Oh yeah. Should have a snake case name. Oh, didn't mean to. Let's see. Yeah, so I need to remove semicolon. That's fine with the variance. Unused import value. That's okay for the moment. 141. So found a reference. LHS prop clone. Or no, RHS prop clone. Maybe I can. Actually, I think that might have been the way it was before. It is down here anyway. So that's just, there's no variant called that. No variant 261. That's to do with the expression location. So I'll go. So let's do it like that. 267 is what? Yeah, so that needs to be a raw expression, and so does that. So we need to borrow expression there, I'd say. I can probably, do I still need the expression at that point? Yeah, I do, for getting the line number information. Even though I have the raw expression at that point. It's a fairly tricky bit of the code at this point. Some other variants, so object destructure on non-object. Yeah, so that should do it for that. Use size cannot be dereferenced. So can I do that, I guess? And spread on object destructure. What was the error message there before? So I had this was in single, I think. So I think I've allowed the error stuff handled at this point. So 284 names in binding, expected reference but got a tuple, so I'll borrow that. 273, what's the issue there? Expected a tuple but got the raw expression. So we have name is the item name. I find that difficult to understand. So what's the name in this case? Is a name from the left hand side that's being used on the right hand side? Doesn't bode well when the meaning is, I mean, evading me this much. So leave the left hand side, the new right hand side. Yeah, so we use it for evaluating the right hand side. Okay, so in this case we're turning the I think it might actually make more sense to do this up here and pass the item name. Like I'd usually rather get the code working before, like I say, playing around with simplifying things, but in this case I think simplifying it will actually help me understand a little bit more. 297. Okay, 261. Not found in this scope again, that makes sense. 141. Expected a reference. So I should be able to just do that. 270. Expected a reference. 286. Names in binding. Let's try that. Just change the lifetime stuff around. Let's see, 319. And yeah, I can remove name from bind next then. And I'll say RH's prop name. And I'll do the same down here as well. And let's see how we go here. I would like to add the name to these parts though. do I need to take a vector? So on line 140, let's see. Yeah, so when calling bind object, surely I can do that. And 287, let's see. The new left hand side expect a reference there as well. Even though I would have thought that that would be bound as a reference. In fact, it possibly will with the new changing the vector of props to be the address of a vector of props. Yeah, and that means that those need to go back in. And what else? If is spread. And then 322 is right hand side proper name. Expected string, so just string. Right. So let's try that. Okay, so are we using, we are using location there. And so let me double check, does this need to be consumed at some point? Realistically, I should be passing the prop name location as well. So let's see, 234 names in binding is in a few places, but not actually mutated anywhere, I don't think. I need to add some tests for that as well. Yeah, I'll go RHS, prop name, location. And that'll be like that. And that's just used there. So I could inline that. Nah, I'll just leave it the way it was. And so name, I also want to extract the location from that, I'm sure. try that. So I'll have a lot of new errors to test for as well. So let's see, runtime errors, and what's the name of that error in the first place actually? Prop shorthand. Is that the error message that I'm getting? Yeah, object property name isn't a variable. And that is object prop shorthand, not var. Oops. Do that to give it a unique name. Okay, and what are the other errors that I'm getting? Well, that's the tests more or less passing, and I need to add the correct line and column information, which is correct in the test output at least, which is good. And I might as well create some, is it in assignment? No, I don't. I guess, is it variables? So I'll add some tests here for the object destructuring. So we'll add a very basic one to begin with. And actually that's interesting what the syntax of this is going to be like. And if it's going to allow renaming. Well, let's start off with a simple test. And we'll see if this works. Yeah, so if I have props, if I have pairs, how will that work? Okay, so that just works as expected. So that's the case of single, and in that case we just look up the variable on the object and we get it. In the case of pairs, how does that work though? I think I'll actually have to read the code to figure out what the syntax is going to look like. I mean, in my head, it would make sense if you gave object pairs so that you could rename them, but I can't remember how this actually gets implemented. So I'll have to dive into that as well. And I'll also need a test for, let's see. Oh, it was on the tip of my tongue there. Well, one other error test I'll also have to account for is when you're mixing declarations and assignments, because you won't be able to do that. Either all the variables will need to be newly declared or else none of them. So in general, you'd probably want to declare any undeclared variables on the line before, and then you can run the expression. So I might add a bit of example code there in the future to account for this as well. Let me think, what was the error test that I was wanting to do? Was it the unspread operator, I think? Yeah, I think so. Or the spread operator, I think. But with that, that's not the feature quite complete, so can't use spread operator in object destructuring. And I'll rename that to capital X to make sure that it gets flagged in the output that I'm not meant to do that. And that'll be column 1, line 2. Cool, so that's the feature at least provisionally implemented. So the basic functionality is there for single assignments anyway. Whether I will actually split up the commit and handle the shorthand and pair version separately, I'm not sure, but for the moment anyway, I'm going to park it there. Feature is implemented, still needs to have some comprehensive testing and failure testing added, and also documentation. I might just add some to-do bits to those files to remind myself. So features, oops, no commit, object destructuring. And that's something that I think, did I see or did I not see in some of the other languages that I was looking at earlier? Can't quite remember, but so I've added it to docs, and I'll add it to the features.test as well. So cool. So with that all in mind and ready for the next time. So that was an interesting stream. I spent the most of it just looking at those alternatives to the language I'm implementing, seeing them in a new light and seeing a lot of the ideas I'm playing around with implemented in those as well. So that's given me food for thought and is making me also think that it'll be worth writing some sample code in these alternatives for a bit, see if they actually scratch the same itches that I'm trying to resolve. and see if any of the ideas that I still have can add to what's already out there. And so, yeah, then I implemented the, I guess, first half of the object destructuring, which is the first part of destructuring in general that I'll be implementing, which will be very useful in general because there are a couple of control flow structures, such as the for loop with iterators in particular, that will make very good use of the list destructuring. And whether I'll have a special syntax for that as well, I'm not sure, but that'll be coming up shortly as well, hopefully. So, like I was saying before, slightly less frequent streams now in the new year, but hoping for people to still enjoy them and check them out when they are available. The Discord channel, so there should be links to that in the description for this video as well, and so be sure to hop by and check it out if you feel the interest to talk about these kind of topics like programming language development and all the rest of it. So yeah, thanks very much for checking out the stream. I hope you have a good day and take care. Bye.